Good morning, everyone. Thanks for coming in. Gartner has a recent research that says in the next 4 years, by 2028, there's going to be a 33% increase of AI agents doing tasks that we're currently doing. How is this number possible? After all, we just started talking about AI agents, like 6-7 months back, after the whole buzz around LLMs. So in the next 4 years, there's going to be a 33% increase. Now, part of this is going to be possible because of all the rich APIs that we've already built so far. My name is Santhosh Srinivasan. I work as a senior cloud architect for AWS. I live in Tampa, Florida. And over the next 45 minutes, I'm going to talk to you about the power of APIs and its role in the agentic revolution that we're experiencing right now. I came across this quote when I started putting this presentation together because I wanted to start it with an inspirational quote. I know it's a cliche, but it's always good to do it. But this quote, particularly from Joshua Block, stood up to me because a few years back, I inherited a product, and I was looking at one of the issues, which was a lot of the UI tasks were taking a little bit longer than it should. Upon closely looking at it, I found an API called /API/complete. That's it, API/complete. I had no idea what it's completing. I had no idea why it's being called, but that's what it was. And it was taking 200 milliseconds, and it was being called in a lot of UI tasks. And this was when we all started moving towards from monolithic to the microservices application. So long story short, turns out when they initially migrated it, they just took everything that was in the monolithic app, each action, and converted it into an API. So people just started, and this was like a state transition to move something from complete. So it was being called every so often. And the new UI developers just started adding it without knowing what it was, because you can't really blame them. What is it completing? So that's why this quote, and the funny thing about it is, turns out it was not completing anything. When I look at the code, all it was doing is just running a query which took about 200 milliseconds, and there was no final action. There was no persistence. Nothing was happening in the API call. Turns out it was refactored a long time back. So that's why it's important to design APIs in a way where it makes sense. And specifically, it should, while it should allow you to do things easily, it should also be in a way where it shouldn't allow you to do the wrong tasks. And now more than ever, this becomes really important. Why is that? We have a new kid in town, AI agents. So far, pretty much all the APIs that we've developed so far have been focused on developers or humans, right? Like you come up with an API, the consumers are going to be other human developers who are going to write some other code to consume your APIs or build UIs to consume your APIs. But now with this paradigm shift that we are going through, we're going to have AI agents going to be doing a lot of consumption of these APIs, right? Gone are the days, or maybe there's still some part of it left, but very soon we will get into that era where you're not going to be sitting there reading API documentation and figuring out what is this completing, and instead your agents are going to be doing those tasks for you. So particularly the implicit promise plays a big picture now. It plays a very big role. You need to make sure that it not only the APIs that you design and you develop, they're not only, and who knows, like pretty soon it's going to be the agents developing the APIs. But in either case, as a developer, as an engineer, our role to make sure that we design systems in a way where it makes sense, not only to the humans, but to the AI agents that's going to be playing a big role in consuming it. So with that being said, the primary goals for this session is going to be, how can you leverage your existing APIs in this AI revolution? What can you do? Because there's so many APIs built out there for pretty much, today when you think about it, our everyday use cases, shopping, purchasing, banking, insurance. Everywhere there's a lot of APIs already built. So there's this massive API ecosystem that you could continue to leverage as you start preparing for this autonomous era, where agents are doing all the heavy lifting for you. Now, that's the first goal I'm going to talk to you about. Next, another big picture here is when agents increasingly start doing these tasks, it's very important to ensure there is a standardized communication so that the AI has a clear idea of what is available to it and how it can perform those tasks. And then lastly, we're going to talk about agentic tasks, which goes beyond like simple, singular automations. So that's where we're going to discuss a multi-agent use case. I've got a sample use case that I wanted to talk about. So we'll discuss how all of these comes into play in a multi-agent automation system. But first, I've been talking about AI agents for a while. So let's just take a quick primer about what AI agents are. Now, we all have used, I'm pretty sure there's not a single person in the room who has not used ChatGPT, Claude, or one of these powerful LLM models that's out there, the chatbots. And while they are extremely powerful, and we've all been amazed at these amazing tools, there are limitations, right, with what you can do with a chatbot. After all, for all its potential and power, they are still reactive. You write a prompt, the model is going to respond to it, and that's the life cycle, right? You just keep asking questions, the model is going to keep giving you the answers for those questions. But AI agents are supposed to extend those capabilities and use the immense potential of the LLMs. And how is it going to do that? By connecting to the real world. And what is it going to use to connect to the real world? In most cases, more often than not, it's going to be the APIs, right? Because when you run a credit card at a point-of-sale system, what's happening over there? There's an API call being made, right? And it goes through your authorization, and you end up getting the response, whether the transaction went through or not. So our real world right now is powered by millions of APIs. So that connectivity is what's going to be utilized by the AI agents. So when I talk about an AI agent, what exactly is the structure? What exactly composes an AI agent? So for an AI agent, you need a program. So that's something that you would create, right? As a programmer, you could use Python, JavaScript, or even Postman has an agent builder. So there's a myriad amount of ways through which you can create an agentic program. But what makes it an agent? It needs to be powered by a large language model or an AI foundational model that's going to essentially be the brain of the agentic program. You'll have tools, and this is perhaps the most important part, which the LLMs normally would not be able to directly access, right? Because LLMs, you just provide a prompt, you give it a text, it's going to respond back. But tools allow access to the real world. Tools allow the agents to perform autonomous tasks using something that's tangible. And then lastly, memory systems. We all know when you close a ChatGPT session or a Claude session, it's going to, for all its power, the next day it's just going to ask who you are. It's not going to store any contextual information. Most of these chatbots operate that way. So for any real-world application of an AI agent, the contextual information becomes extremely important, right? For a system to be aware of its surroundings, to know what exactly it is supposed to do, that contextual information where it identifies what it's supposed to do with all the tools that are available, and being able to store that in a memory area that it can access, that's another pretty powerful tool at its disposal. So these are the components at a very high level, these are the components that composes an AI agent. Now, what makes an agent different? The way it's able to perceive its task and then act upon it. So I call it, you can call it the agentic loop. It does not have to be a loop in the traditional sense, but think of it like you have a task to perform. You ask the agent to perform the task for you. It's going to perceive that task, Then it's going to reason how it's going to perform the task, because there's always going to be multiple paths in how it can achieve the task, and it's going to act on it. The way it's going to act on it is by executing the tools. So that's where and we're going to talk about that in more detail. Then it's going to observe the result and reason again whether it was able to perform the task to a satisfactory level. Has it completed? Has it accomplished the task? And if all is well, then it's going to complete it. If not, it's going to reevaluate the plan and then start again. So that's the agentic loop. And this is something that is going to be pretty standard for most agents that you would develop to complete any objectives. So we saw what an AI agent is, what is its structure, how what makes it different from just a standard LLM model. Now, how do we leverage existing APIs with agents? And why is this important? Again, I might sound like a broken record throughout this presentation, but one of the primary goal is that with my presentation is to make you aware that there's this massive potential with this ecosystem that you want to, it's basically an art of possibility, right? What all is possible with your existing APIs. So there are thousands of APIs that are built. How are we going to leverage it, right? So I'm going to start with LangChain, which is one of the very common frameworks for building AI applications, specifically around agentic applications. And I'm going to use this as an example to get the point across, right? So I talked to you about the tools that empowers the agents to go beyond the traditional chat system and execute actions. So that's why I wanted to use this LangChain, because it's easier, and we're all engineers and technical folks here. So I'm going to take an example of this code. And if you look at this, it's a pretty standard Python function. Don't worry too much about what's in there. It's a weather function. I use the weather because it is very easy to get a point across using. Everybody is aware of I check weather 5 times before I go to work in the morning. So it's a standard API that gives you the weather for a particular location. Now, if you've asked about this weather-related questions to any of the chatbots, I think now there are a lot of real-time interactions with the latest models. But previously, when all of these models had a cutoff date for their training, they were only able to respond to questions until the day their training ended. So if you ask any recent questions to these LLM models, they wouldn't be able to respond appropriately. And that is where these agentic tools comes in, because in addition to what data they are already trained, how can the LLMs get access to the latest updated information? Weather being one of those, right? Because it changes every day, and it's going to be, there's a lot of forecast that's going to keep changing. So it's a real-time information. And how does an LLM can get access to it? So in this case, you would see that I've used an add tool decorator that is available as part of the LangChain framework. So what it allows you to do is essentially have a function where you can make a call to your existing APIs and wrap it up in this decorator, which makes it easy for the agents to execute that call. So now what happens is, when you execute that agent program, this agentic program, with the tool being available to the agent, it can easily call the weather API, right? So this was now in a traditional LLM model where it is after that particular training cutoff date, this was not going to be possible, right? So that was just a very quick example to get you acquainted to how you would use an existing API and wrap it up in a tool and build a very, very simple but powerful agent to get you weather forecast. But that's just the beginning, right? Excuse me. So that's just the beginning. There's a lot of real-world use cases that you can use this for. So think about the examples that I mentioned at the beginning of the presentation. Your banking transactions, your e-commerce and retail transactions. You could have AI agents wrapped around all of these existing workflows that we already have. And it's going to be really, at a very high level, as simple as wrapping those existing APIs as tools, right? And then have these tools made available for the agents. So another example is CRM. A lot of people here, I'm sure, is aware of like your customer relationship management tools to managing your leads, your prospects, and so on and so forth. So these are things that, think of an AI assistant that can manage your entire lead and your marketing pipeline for you. Now, it needs to be able to, while it can make all those reasoning, unless you give it access to your existing CRM tools through these API functions, they won't be able to persist that data or be able to reason and retrieve the specific data you're looking for. So with that, let's look at another basic example. Again, this is just so that we could get acquainted with the idea of agent and the ability for the agent to use tools. Think about this very simple API endpoint, orders, right? It can take a payload, and it can submit an order for processing for, let's say, a retail store. Now, for this example, I'm using a framework called CrewAI, which is another agentic framework, which is particularly useful when you have to use multiple agents. Like if you are going to use different types of agents, and we'll talk about, that's one of our goals, so we'll talk about that a little bit more in detail. But this framework is particularly useful when you want to do manage a fleet of agents. So in this case, I'm setting up an agent. I'm giving it a backstory on what it's supposed to do, like what's the role of the agent, and providing tools for that agent, right? And the underlying LLM. So if you look at the way the method call is structured, I'm providing it the LLM, the tools, and the context. So everything that we saw as part of the, if you remember back to that slide for the anatomy of an agent, we're providing all of that when we set up that agent. Now, the tool, right? Again, very similar. It's an API call to an existing endpoint that we already have. And all it is like proxying the request so that the agent can place that order. And of course, the actual task itself is to be able to run the agent as part of a crew. Now, in this case, I've got one agent, just as an example. But typically, this is where in a retail system, you would have one agent processing order, another agent perhaps processing inventory, keeping track of what is available, what needs to be restocked, maybe a different agent that's processing deliveries. So these are the kind of capabilities that you would build. And then you would run it as a crew of agents, or as a fleet of agents running together, each interacting with each other. So with that, what I wanted to say is the simplest way you could begin thinking of agents, envisioning your life and the type of work that you do, and what are the possibilities that you can leverage with the APIs that you might have access to, that you might be using already. Now, there is one standard problem. If you have built agents in the last few months, there were, especially before the recent advancements, one common issue has been the foundational models didn't have good contextual information on how to query these tools. So we can build these tools, we can offer these tools to the LLM models, but now the models themselves have to be smart enough to know when these tools can be used, or when these tools should be used, in what context, right? That is what makes this an autonomous system. Because the agent, by itself, if you are going to program each and every step of how the tool needs to be called, then that's not an agent, that's just simple automation. But the real power of the agentic system comes in because the model, underlying model, makes the decision on when these tools needs to be executed, when these tools needs to be invoked. And the last few months, most models had issues trying to understand when they should invoke a particular model. And this was probably, in most cases, this was because the type of API, going back to that original quote and the story that I told you before, most APIs, they were built for human consumption. So the models had a very difficult time understanding the request and the responses that was needed to build these, to invoke those tools. So there were other issues like error handling, right? It's a very common thing. You build any program, you need to be able to handle errors in a way it makes sense to be able to recover from those errors. And of course, mapping the inputs and outputs, right? Because you have an API, which is an external system, and you're building this agentic program. Now, how does the agent knows what input it should use to invoke those APIs? And how can it interpret the responses that's coming back from the API? Both of these are very important, crucial parts of any agentic system. And of course, there's other issues like authentication and authorization, security, which is like the fundamental aspect of anything that we have to build. That is where people started to think about standardizing everything that an agentic program or an agentic AI uses in its execution. So enter MCP, Model Context Protocol, right? Think of it as a universal translator. The MCP website from Anthropic, if you look at it, it says it's a USB-C for agents. That's the definition that they have. And it's essentially what that is, because it offers a protocol, a specification that any agent builders should start using. And what does that give you? This ability to standardize the specific, to follow the standardized specification will ensure that people who build agents, they can interoperate with each other. So all the cross-execution between, like if I'm building an agentic system and you're building an agentic system, for us, both of us to be able to talk to each other, if we are MCP compatible, it makes it easier to do that. It gives the LLM a semantic understanding of how they perceive the request and responses. And not only that, the tools, the prompts, everything that makes up an agentic system will now become standardized and wrapped in a specification so that it's easy for us to interoperate with each other. So think back to the common problems that we talked about, right? Discovery and understanding. How does, now, in the examples, the simple examples that I showed you, I created the tools, and then as part of the agent program, I just provided those tools to the agent. But that's a very simple use case. Think of more advanced systems, right? Even taking the retail example. If I have a lot of vendors, and if I have to be able to interface with each of those vendors to be able to consume their stuff, how would I know what are the capabilities that are available? As an agentic system, how would I know what capabilities are available? There should be some form of discovery, right? I should be able to query the tools that those external systems have before I can actually invoke those tools, right? So that's a very integral part of this agentic system, discovery and understanding. Error handling and resilience. So we talked about how important it is to be able to map those, to get those handle the errors in a way it makes sense to be able to recover from it. So MCP allows you to follow a certain type of specification that makes it standardized on how you handle these kind of errors during your agentic execution. And then perhaps the very important part, the input and output mapping, I think it's a very vital part of it because, and it goes to the first point as well, discovery and understanding. To be able to know what tools are and what each tool does, to list down those tools, to specifically map out when to use those tools and how you would use those tools. All of that is now standardized thanks to MCP. So without further ado, we'll just jump into a quick example of how MCP works, right? So think of this API. I've named it in a weird way. It'll be apparent why I've named it cave carrier, but ignore that for a second, right? So it's a pretty standard Swagger specification for an existing API. It's got a bunch of endpoints, like being able to being able to inventory of products that's available for cleaning a cave, I guess, and being able to do a deep cleaning of the cave. And again, I promise this will become apparent in a second. So when I have typical APIs like that, MCP gives you something called as a fast MCP, which is at the heart of the model context protocol. This fast MCP is a SDK that you can, it's a specification, but more than that, there are SDKs for different languages that you can use to run your MCP server. So this is the primary, the critical part of it, right? Because this allows you to immediately utilize any of your existing APIs and convert them into tools that any agentic system can understand. So let's say if I have a business running, again, I'll go back to the retail environment, right? So if I have a retail shop and I have inventories that other multi-retail needs to be able to invoke, by using MCP, I can build an MCP server, which is as simple as this, right? You have a decorator, mcp.tool. You can wrap it around like essential API calls, and then you can, we'll talk about some ways to optimize it. But think about each of your APIs could essentially become tools. Your endpoints will essentially become tools, and you offer that tool to your, you build a MCP server and run it. Now, this MCP server will become the main interface for any agentic systems to be able to invoke your endpoints. That's a lot of power, right? Because immediately you are able to provide access to several agentic systems by building an MCP server. And this is, in fact, what a lot of companies have started doing, right? They've all started building MCP servers that your agents can start communicating with. So for instance, for this sample that I just built, I used Claude Desktop because it's an easy way to test out MCP servers. So you can actually configure Claude Desktop to read your local MCP servers that you're running locally. And then you see I've got all the tools that I built. It's all there. The get room status, clean all rooms, get inventory. These are all my APIs that have now become tools for Claude. And how does that help? So I just asked, can you check if the kitchen is clean? No context whatsoever, right? It's a Claude Desktop. It's a third-party tool. No context. I just asked, can you check if the kitchen is clean? And Claude knows that these tools are available, and it's able to go invoke the API, the underlying API, using the tool that I have set up. Then I said, can you check all the other rooms? And it's able to do that. It's able to give me all the rooms that are available and the state. Again, these are actual JSON API responses that comes from the API that I showed you. But Claude, and if you look at the code that I showed you, I'm not doing a whole lot of API massaging, right? It's a pretty standard stuff of proxying the API request. But Claude is able to understand the responses. It's able to interpret that. And how is it able to do that? Because MCP makes it easy to expose those tools, right? And because of that, Claude is able to query the list of tools that are available and map out specific requests to specific tools, and then go ahead and invoke those tools. Now, this is an again thing. Another tool invocation based on my request, which is to, can you go ahead and clean all the rooms? And then it knows exactly which API to invoke through the tool. So how does this work? The MCP architecture primarily consists of 3 components: the MCP server, the MCP client, and the host. So the MCP server is what we talked about so far, right? This is perhaps the easiest way. I get asked this question a lot. How do I start with AI engineering? How do I get into building agentic systems? And my response is, start with building an MCP server. That's perhaps the easiest way you could get started with it, because you can take your existing APIs, just slap some tools around it, and then run your server in your own environment, and then give access to other systems. But what is the component that's reaching out to the server? That's the MCP client. So MCP client is something that you could build using existing extensions or SDKs. And that allows you to essentially query the MCP servers And usually, the client will be part of a larger system. So in this case, the example that we talked about, the Claude desktop is considered that as the MCP host. It's a standalone system. And Claude desktop will have some sort of an MCP client, which is able to go query the MCP servers that I set up. So these are the three primary components which makes up the MCP ecosystem. Now, within the MCP server, you could have tools, which I just talked about. You could have resources. Resources are nothing but standard things that you would access, like your file system maybe some configuration or context information that you're storing somewhere. And you could have prompts, a prompt library, which specifies exactly how and what kind of prompts are available to your agentic systems. So you could store all of this as part of your MCP server and make it available for the agents that's invoking your server. So we've talked about a bunch of different stuff now, which brings us to the final segment of the presentation. So we saw how to empower your existing APIs. We saw the need for standardization. And that leads us to unlocking the real capabilities of agentic systems, which is a multi-agent workflow. Because more and more, when we start this journey towards this automation, one agent is not going to be able to do everything that you need. There's going to be specific need for building out a multi-agent system. And the reasons are that you need modularity, right? You need specialized agent that can independently scale and be robust enough that it can handle different types of queries and responses. And the most important is the expertise, because these agents need to be specialized in what they are doing, and they need to be able to call those special tools that are available to them. So presenting Alfred AI, right? It's a fictional use case that I came up with for the purpose of this presentation. I am a Batman nerd, so I chose Alfred AI. So I hope most people here are aware of Batman. And if you don't know, Batman is a superhero from DC Comics. And he has a butler named Alfred who helps him with his day-to-day tasks. Now, Batman is high maintenance, right? He fights crime through the night, and he needs a lot of support. And Alfred is an old butler. So think that it's time for his retirement. So he's building an AI out of his persona. And because of that, another thing that struck me always is, how is Alfred the only person in Wayne Manor doing all the things? After all, it's fighting crime is a very big task, and Bruce is going to need a lot of support. So think of the three agents, the three other personas here as additional agents for the Alfred AI. So we'll have a chef, we'll have a cave cleaner, and so that's what that cave cleaner example was for, because it's a bat cave. There's a lot of bats. I think it's going to need a lot of cleaning. So, and then we have a fun master, because after a long day of fighting crime, you're going to need to have some fun. So those are the three sub-agent personas. And we'll have the Alfred AI will be the main orchestrator between the three different agents. So we already saw the cave cleaner API example. We'll have some more APIs for managing the entertainment, where after a long, tiring day of crime fighting, he's going to need some music, perhaps watch some movies. And then he's going to need a lot of calories, right, to keep himself ready for the next day. So there's going to be like a set of APIs that allows him to make, to feed the occupants of the Bruce Manor. So those are the three different APIs, and we'll have three different agents that's going to be working on these specific specialized tasks, right? So how does that work? There are a lot of ways in which you could build these kind of multi-agent systems, where you could have one primary agent orchestrating the tasks, the specialized tasks between the three specialized agents. The examples of APIs that we saw, Those all could be individual tools that each of those specialized agents will have access to. And then the orchestrator agent, because you're not going to be, think of this example, right? It's not going to be you who's going to coordinate with each individual AI agents. That's not going to be a good experience. You're going to have a primary interface, and that primary interface is going to be able to orchestrate. So how does that orchestration work? Again, enter MCP, right? Because you have these specific capabilities that you are now exposing as tools, each individual agent can expose those tools to the main orchestrator agent. So it'll be like Alfred querying and saying, hey, I need to prep meal for Bruce. So what are my available options, right? And then the Star Chef agent is going to invoke their API and then find out what are the available recipes and cuisines that's available. And then Alfred's going to go ahead and do another tool invocation saying, OK, that sounds good. Go ahead and make this. And then the Star Chef agent is going to go ahead and prepare that food. So this is, again, an idea of now, this is a fictional idea, right? But think of the potential of something like this. And I'm pretty sure there's already companies doing things like these, like home automation. I read that there's a lot of work going on in that area. Who knows? We might all have our own version of Jarvis from Iron Man pretty soon, doing, attending to our whims and fancies in the future. But this is, again, to show the potential of how you could define multiple agents and then work between them. So when I set up this example and ran it locally, this is the kind of the output that I got, right? So I defined those 3 agents, each with individual tools, and then I executed it through Claude. And you see I have Alfred responding to me, describing all the staff that's available, and then each of the tools that that's available to the staff. And then I went ahead and said, I have a party, so go ahead and get everything ready. And you see that it's not just one tool call, like I showed you before, but for one prompt, each of the rectangle boxes that you're seeing, each of those are individual tool calls made by individual MCP servers, right? So the get hygiene status is from the cave cleaner. The search recipes is from the Chef API by the Chef agent. And then the get available music genres is from a different server. So you see how one request, one prompt, has led to multiple invocations of tools. And again, none of this, there's no context, additional context that I have provided to it. All it is just MCP servers that was built out. And Claude is able to understand what are the tools that are available. And again, I use the Claude example, but most LLMs, most foundation models today, I'm sure are able to, once you define it in an MCP compatible structure, they're able to do this. So yeah, more examples of how it all summarized. After it executed all the APIs, the Alfred AI is able to summarize the responses and then provide a final summary option of how that worked. Now, so what does that mean? So designing robust multi-agent system is going to be a very big part of what future AI engineers will be doing. So the things that you need to watch out for: clear agent responsibilities, right? So you want to make sure that each agent is modularized, like we talked about. Being able to standardize the communication between those agents. Dynamic task delegation. That's what we saw, where I didn't specify which task or which tools to execute for what kind of prompt. The model is able to do that by itself. So that's dynamic task delegation. And then observability and monitoring. This is not spoken about a lot, but especially in the AI world, observability is going to be very important because otherwise you're not going to be able to know when, how much you are spending, especially with the cost of AI increasing. You need to know exactly, how much you're spending, and the token length and a lot of other things play a big role when it comes to observability. So with that being said, our future is going to be orchestrated. There's going to be a lot of things that we do manually that's going to be automated. So make sure to be part of that revolution. It's going to be an interesting time. It's an interesting time that we live in. But the main idea behind this is that APIs is going to be playing a central part of the revolution. And lastly, there's a lot of ethical, moral considerations. This is still a very new area, and there's a lot of things being in play. So always practice responsible AI implementation with any work that you do. So I hope this was interesting and informative. And since I think we're on time, so I'll be happy to answer any questions outside if anyone has any questions. Thank you.